Founded in Turin in 1936 as a manufacturing concern, is today a holding in charge of all the strategic, financial and coordination activities of its subsidiaries. FATA is a diversified group of companies, leader in engineering, contracting and manufacturing. It's a Finmeccanica company. Finmeccanica is an Italian industrial group which is playing a leading role in sectors such as aerospace, defense and security, information technology, transport and energy. FATA, through its EPC division, engineering, procurement and contracting, and thanks to its many decades of experience in the implementation of automatic storage and retrieval systems, mainly at great height, has developed and patented an automatic system for container handling called Teostack, which is conceived and developed for harbours and intermodal terminals. In the last decade, the transport of goods through containers has witnessed a continuous growth, and projections show that such growth will increase in the forthcoming years. The handling of the containers from and to the ship is carried out by means of key cranes, which retrieve the containers from the ship and deposit them either on the trailers or onto the quay. Different kinds of equipment are then required to handle the containers towards the storage areas, which are often far away, and to park them by means of trailers, reach stackers, RTGs, straddle carriers and the like. In order to keep a compatible rhythm with the increase in dimensions of the ships and with a great quantity of containers to be handled, each crane requires many of these types of transport, both in operation and in standby, to enable the maintenance required for this wearing type of activity. Such a traffic on the quay, in particular near the cranes, represents a potential source of conflict between the different operations in progress, and subsequently also an intrinsic limit to the development of the full potential of the cranes themselves. The skill and care of the operators, because of the precarious safety conditions, mainly when inserting and removing the twist locks, are essential factors for the execution of the different maneuvers of container handling. The information is either entered by the operators on wireless systems or transmitted by radio. Complex software helps to manage this variety of transportation and information. In this cycle, the human factor intervenes several times, with intrinsic risk of error. The overall number of containers stored in an average harbour may reach several thousand units, including full, reefers and empty ones. In order to store them in the available space, the containers are stacked in 4, 5 and even 6 levels, with the subsequent increase of the shifting operations, i.e. unproductive movements. Wherever room is available, the containers are stored on 2 levels in order to limit the shifting operations. In this case, approximately 100,000 square meters are required to store 6,500 TEUs. Security and the increasing need of ascertaining that the containers do not contain any forbidden and/or dangerous materials are nowadays unavoidable. The safety standards and the execution modalities of the non-intrusive checks, i.e. X or gamma rays, call for time and a personnel-free area. Consequently, no more than 5 to 10% of the containers are checked at a remarkable cost for each container. Teostack is a handling and storage system for 20-foot and 40-foot standard and refrigerated containers, and upon request for other types of containers such as high cubes. The system is installed downstream of the quay crane and thus remarkably reduces the need for self-propelled transportation and introduces all the benefits of automation, such as the increase of both performance and efficiency of both the container terminal and intermodal terminals. The unloading cycle starts as soon as the crane deposits the container on the purposely allocated reception device, which is set on the movable platform at a height of approximately 20 meters from floor level. Once the container is deposited, the crane is free to release the spreader and start a new cycle, without any need to wait for the operators to either release the twist locks or reset them in the loading operations. The cycle time of the key crane is reduced because of both the shorter vertical stroke and the elimination of a non-productive waiting time. An optic reading station detects the container data and transmits it via an information network to the tailstack management computer, which coordinates and controls all the movements of the system on compliance with the instructions received from the terminal management software. The turning distributor, which consists of a turning platform trolley and a stacker, stores the container into the closest free cell and returns under the twist lock platform for a new cycle. Moving inside, we find other machines, the shuttles. They provide for the horizontal handling of the containers between the cells of each floor. The shuttle consists of a sliding trolley with a stacker on board, similar to the one seen on the turning distributor. The vertical transfer is achieved by the elevators, which are appropriately distributed along the aisles. Once it reaches the destination floor, the container is retrieved by a shuttle, which takes it to its final destination cell. The horizontal transfer between the different modules of the tailstack is carried out by an operation similar to the one carried out by the shuttles by stackers located in purposely allocated cells. All movements are carried out at the same time on the different floors. This arrangement allows separating the horizontal movements from the vertical, with remarkable advantages on the cycle time. The location into dedicated cells allows for the direct immediate access to all the containers stored in the tailstack, thus eliminating any need for shifting. On the land side, a shuttle, like the previous, extracts the containers and transfers them to the selected unloading position. A bridge crane with turning spreader transfers the container to the trains and/or trucks in the loading area. The system is able to perform combined cycles for loading and unloading, thus minimizing the idle movements of the equipment used. The absence of operators in the whole internal area of the tailstack system enables the integration of monitoring systems such as gamma ray scanners, thus enabling radiographic inspection during the standard transit cycles without loss of productivity. The development focused great attention on the reliability of the system, providing duplication of the vital functions of equipment, fast access, reduced intervention time, in order to guarantee the maximum efficiency. The space saving which can be achieved is obvious. 8 levels enable to house 6,400 TEUs in 25,000 square meters versus the approximately 100,000 square meters required for ground storage on 2 levels, i.e. the one which minimizes the shift in operations. Erection and commissioning of tailstack does not affect the normal activity of the container terminals. Once tailstack is operational, the key area used enables the circulation of traditional transportation for the loading/unloading of containers and special goods. The landside interface makes tailstack particularly suitable for use in intermodal terminals. If the seaside interface is replaced by a landside one type, trains and trucks can actually be served on both sides. Another advantage of its use in the intermodal terminals is the simplification of the railway track bundle. When tailstack relocates the containers within its system, it can transfer them directly onto the truck or the railway wagon they are allocated to, irrespective of the origin and/or destination of the container itself. The main equipment of Tailstack, the shuttle, has been did by using a prototype which was reconstructing a section of aisle of a limited length and a given number of adjacent cells. The shuttle was programmed to carry out reiterated retrievals and deposits of 20-foot and 40-foot containers, each time performing a full return cycle. The tests were totally successful and confirmed all technical aspects. In short, the advantages of Tailstack can be summarized as follows. Space saving 50 to 70%. Direct access to all the containers, i.e. no shift in operations. Productivity increased by up to 70%. Total modularity of the sizing as related to the space available and expected growth. Security of the containers because of limited access. Full reliability of operation and running. Standardization of the equipment. Redundancy of the components. Improved environmental impact. Considerable reduction of polluting fuels. Tailstack, the solution for those who look at innovation as a necessary step for a quality leap towards the future.